This is our second proof in 5.4 day 2, and this is kind of the big scary one for the day. But one thing I want you to do is, if you have a chance, go back and look at your notes from 5.4 day 1, because this sine 3x thing, that what we're going to do with that is really similar to what we did with it in day 1, just as a proof instead. So take a look back at there, you'll recognize some things once you do. First thing is, like last problem, we want to get rid of this multiple angle thing in here. So we're going to use the double angle identities, but that's a triple angle, so we have to split that up first. So first step in this place is to, well, we have sine x, that's staying as is, and then we're going to do sine of 2x plus x to split that up. Now the reason we're doing that is so we can use a sum and difference formula to split it up, and then use a double angle formula to get rid of the 2x in that part. Alright, so next step is to split it up. Sine of 2x plus x, we are going to be using this sum and difference formula to split that up. I'm going to run into a little bit of a space issue here, so please bear with me. We've got sine plus, now we have sine 2x cosine x plus cosine 2x sine x. All this equals 0. Now again, we have to get rid of these 2x's, cosine 2x and sine 2x, and so that's a big part of what we do here. Do that next. Now sine 2x, that's got one option, that is this option right here. That's nice, it's very straightforward, and so we just do 2 sine x cosine x. That's what we're replacing, but there is still a cosine x on the outside, so don't miss that one, please. And then for this next one, cosine 2x, here again, like I mentioned yesterday, we have to make our best guess because there are 3 different options for cosine 2x. And we're going to choose the one that we think is going to have the most relevance to what this is. So I want you to notice here that we're going to have cosine squared, but we're not going to have sine squared when we put these things together. So I would just choose the one that involves cosine squared in this case. Again, if you make a wrong choice, you can always go back and correct that. It's not a big deal to do that. It just takes maybe 1 or 2 extra steps. So unless you're really afraid of doing extra steps, might as well just choose one. Alright, and then we have that times sine x, all equal to 0. So now we have all this stuff written out. Let's combine some things, the things that we can. Sine x is still just going to stay as is. 2 sine x cosine x times cosine x. We don't distribute, but these two multiply together. And so what we get here is plus 2 sine x cosine squared x. And then over here, we are going to have to distribute this sign, and so I want to make it look as much like that as possible, so that we'll go 2 sine x cosine squared x, and then minus sine x equals 0. Alright, so now we're completely expanded. The next thing is to take some of these and get it simplified down if we can. One nice thing about this is that we've got a positive and a negative sign, so those just are gone. And then in here, take a look at, we've got this is exactly the same as this. So if you have, it's kind of like saying 2x plus 2x equals 4x. And so now we can do 4 sine x cosine squared equals 0, and that's much simpler to deal with. Now we can just split it up into 2 equations. The 4 doesn't really make a difference because anything multiplied by 0 is still 0, so we can ignore the 4. One of our equations, many equations, is going to be sine x equals 0. The other one is going to be cosine squared equals 0. Now we do need to get it just plain cosine, so if you take the square root of both sides, we get cosine, and square root of 0 is still 0, so we get sine is 0, cosine is 0, and then again we're going to be looking at our unit circle to identify the different solutions. Actually this one, sine equals 0, that was the same one that we had in the last problem where the y value equals 0, so there's 1 and there's 1. We're at 0 and pi for sine. So x equals 0 and pi. Those are two of our solutions. And then for cosine, we have cosine equals 0. That just means where's the x value equal to 0 in our unit circle. And that is going to be, here's one where the x value is 0, and here's the other one where the x value is 0. So there's pi over 2 and 3 pi over 2 are our other two solutions. So actually all the quadrantal angles in this case are going to be solutions to this equation. So that is it. And again, you want to check them in the original, see that it works out, but that pretty much does it for this example.